Hello everyone, I'm Lee. In our previous classes, we worked hard on the first principle of OOP, that's data encapsulation. It's time to look at the second and the third principle of OOP now, which were inheritance and dynamic bonding. So in this video, we are going to focus on inheritance, and we are going to look at the two most popular design of OOP, the is a relationship and has a relationship. So first, let's take a look at a simple sample project I put together. So we are trying to model a bunch of shapes such as circle, rectangle, triangle. So assuming in a drawing program we need to model those shapes. So think about with circle and rectangle or triangle, they all have different attributes. For example, for circle, you might want to model the radius. For rectangle, you might want to model the width, the length, etc. But they have one thing in common. So I also want to model the x-coordinate and the y-coordinate of those shapes, or the position of those shapes. So where do I put that code? How to model the x-coordinate and the y-coordinate code? So if I put them in individual classes, such as in circle, in rectangle, I have to duplicate the code. So I have to model XY coordinate in all these classes. So it's tedious. And also, whenever you have code duplication, you should raise a red flag to yourself. That's not right, because that means later on, when you modify that part of the code, that means you have to go to all the places you have those duplicate code to modify them. If you leave one out, then you get a bug. So code duplication is our biggest enemy. So what we need to do is we need to put it in one place. So inheritance comes into picture. So we recognize one relationship. We say circle, rectangle, or triangle, they are all shapes. So this is a relationship. Like a circle is a shape, rectangle is a shape, triangle is a shape. This is a relationship allow us to say, hey, get all the common things, common attributes among you guys and push it up into this shape class so that we can model it once. And circle says I'm a shape, then you can just inherit all those common attributes. And rectangle is a shape, so you don't have to implement those common attributes anymore. We push them up in this class hierarchy in the shape class. So our plan is to model all the common attributes among all those shapes in this one parent class, or we call it a superclass. In this one parent class, model it right there once and let those guys inherit from this superclass. So there are some terminologies. Sometimes we call this a parent class, those child class, and lots of the time we call this is a superclass, those are subclasses. And this relationship called is a relationship. Please pay attention to this symbol here, the solid line with a little triangle at the end. So that means circle is a shape, rectangle is a shape. So you see, use a relationship, like for example test shape, use shape, you use a dashed line here, and use relationship, you use a dashed line and an arrow here. And how about position? Position is something I want to model x coordinate and y coordinate, or maybe z coordinate if it's a 3D thing. So why do we want to create a separate class? Think about this. Circle, rectangle, and triangle, or all the other shapes, they might have more than one attribute in common. So not just position. Maybe they want to model color, want to model is that bolded, shaded, or something like shaded area, or things like that. So we want to push up all the common attributes among those shapes into this parent class. And we don't want to spill out implementation detail all in shape class. So for example, if we want to model x coordinate and y coordinate, we want to create a separate class called a position class to encapsulate that implementation detail. Then in shape, we just use position class to model the detail about x coordinate and y coordinate. The nice thing about that is it's more readable and it's more maintainable. If you want to change the implementation detail about the position, you just go to position class. You don't have to model the shape class. Alright, so you see, in this sample project, we're going to demonstrate two relationships. One relationship is a relationship that inheritance. Circle, rectangle, they're both shapes, so that means they can push up the common attributes into shape class, and they just inherit from the shape class. The good thing is now circle can focus on what's specific about the circle, and the rectangle can focus on what's specific about the rectangle. They don't have to reinvent the wheels anymore. So inheritance, the advantages you can easily see, like code reuse and easy to maintain. Later on, when you want to change something about those common attributes, you go to one place instead of many places in those subclasses. That's the first relationship called the is a relationship. That's about the inheritance. And another relationship we see here is shape is going to use position class to model the xy coordinate. So that's a use a relationship or has a relationship. Shape object has a position object to manage those attributes for us. Alright, then test shape is just a client class to test this hierarchy. So with inheritance, you can see when you go up the hierarchy, it's getting more general. When you go down, it's more specific. And in this diagram, we only see circle and rectangle is a shape. Actually, there's another one we didn't show here. Remember, everything in Java is an object. So in shape class, even if you don't say explicitly I'm a subclass of object class, it's an assumed relationship. So everything is an object. So up there we should have another line and a little triangle, and that's an object class. So with this design, like everything in Java is an object. Because for a class, if you say I don't have a parent class, then that means your parent class is object class. So you can imagine circle has a parent class shape. Shape has a parent class object, and object class is everyone's grandparents or great grandparents. Alright, so in the next part of the video, we're going to focus on the implementation part. We're going to see in Java, how do we do the inheritance relationship, how do we inherit stuff, and how do we model the has a relationship. Thank you.